We'll now be heading over to our winners of the Jury's Choice Award. Can we hear a roaring round of applause for T-Systems ICT India, our winners of this award? Let's see what they have to say. Over to you.
Hi everyone, my name is Arpita and we are here to present the Project Juno, which has been chosen for Jury's Choice Award. I would like to thank DevOps India Summit 2022 for choosing Juno project for this Jury's Choice Award. So I'm the service delivery manager for this Project Juno, along with the container COE, which has several container-based application operations projects. Today we'll talk about what is Juno, what is Project Juno, its business significance, its business impact that we have, what is so unique about Juno, and probably the tool chain architecture and the service improvements we have brought about. And followed by that, we'll talk about the service pipeline and the data ops operations setup that we have built. So what is Juno project? It's a platform that has been developed for an automobile manufacturer to host the backend services with an added level of security and privacy. At the same time, we are migrating from on-prem data center to the public cloud, the microservices that our customer has. And VM-based applications are getting moved to the containers with this project. Now let's talk about why this added level of security. Because the applications that are hosted on this platform, those are end user facing, meaning to quote a few, there's an application which stores the personalized settings of the driver. Then there is an application which stores the details about fuel consumption and so on. So the impact here is that if this platform doesn't work even for a few minutes, it means that in-car communication will stop. So to quote an example, there will be no navigation from the car. So that's the impact, and that's why this high level of security. To cater to these requirements, you can see on the screen, we have this tool chain architecture to cater to these requirements. Now, Microsoft Azure is a public cloud that we are using here, and we are using it across the regions like EMEA, AMAP, and China. And we have hub and spoke model over here. You can also see it on the screen, wherein each Kubernetes cluster is a spoke. The spoke cannot talk to the other spoke directly. It has to talk via hub. And we have different hubs at different stages, dev, prod, and non-prod. So to summarize, every application hosted on this platform may have 9 clusters pertaining to the regions and pertaining to the stages. Now, because this is a migration from on-prem to DC, there are huge Postgres databases, and we have fully managed Kubernetes to take care of container workloads. Then something which is very unique about this platform is the encryption. So because we are dealing with quite confidential data into our environments, we have to encrypt all the VMs. And this encryption requirement is taken care of by the software called as HITRUST. Now this HITRUST key control is the right name of the software. This uses backend and agent approach. So in the backend, we have all the details related to encryption, like the keys and the policies. An agent is installed on each VM, and it uses those policies. So agent decides which disk is to be encrypted using what algorithm, and so on. And we have 2 interesting policies defined over here. So first policy is, if there is no communication between the agent and the backend, then for let's say 8 hours, then VM is shut down automatically by the agent. The second policy is if suppose VM is rebooted, then the agent on the VM needs to be authenticated in the backend. And if this communication is broken between the backend and the agent, then the agent won't get rebooted and VM won't start. So those are the policies that make this entire solution very much secure. And this communication between backend and the agent is always initiated by agent, and it is secured via HTTPS. It also has a part of certificate. So for example, the agent will have a client certificate which is authenticated by the CA of the backend, and it will have information, all the information related to VM, like the IP address, or for that matter even the hardware specifications. And uh, what happens is backend is able to identify each and every VM individually, so it won't allow uh, any VM to intrude unless it is authenticated. On the other side, even the client can verify the server certificate of backend by its CA. So this is the entire setup of high trust or encryption. It is complex in itself, and it is all the more complex because probably this was never done before on a containerized workload. Now we spoke about this encryption of VMs, but it's not sufficient. So another requirement is that the traffic that flows between the nodes or the pods, that also needs to be encrypted. And for that, we are using WireGuard encryption, which uses cryptography to create secured or encrypted tunnel between the pods. So these are the main technologies that we are using. Over and above that, we have Calico for pod networking, which is used to establish pod-to-pod communication, setting the IPs for the pods. Then we have Nginx Ingress. We have Consul for service discovery. If we talk about logging, monitoring, and alerting, then we have Fluendian ELA for logging. We have Datadog for monitoring and OpsGenie for alerting. So uh, you must have seen that we have such a rich toolchain architecture, and that's the crux of it. We have dedicated CI/CD so that each of these can be catered to as part of the packaged offering. With that, we'll move to the next slide, which is operational excellence or the service improvements that we have brought about over the time. So here, we have achieved this operational excellence via a viable combination of DevSecOps, SRE, and continuous improvement. And those are the three pillars that you see on the screen. When we talk about DevSecOps, we already have robust encryption system, but over the time we have improved over it. We have evolved in it. So apart from the high trust encryption improvements, we have also changed our pod-to-pod network traffic encryption from IPsec to WireGuard, because WireGuard is modern, simpler, and more safe than the IPsec. And this is something we've done throughout the life cycle of this project, that whenever we found something better than what we already have, we have taken the bold decisions and we have gone ahead and adapted those things. Then we have role-based access control. So we have roles set up for all the teams that are involved in this project. We have very robust certificate management process. We have automated notifications 30 days before expiry of any certificate, any type of certificate for that matter. We have auto certificate renewals on, and we also have a dashboard where you can see single view of all the certificates. Automation is something I would say which is the USP of this project. So we have an Ansible playbook for creation of clusters, and it is divided into 6 layers. So starting with cloud provisioning, then OS setup, uh, encryption, Kubernetes installation, tools installation, and lastly post installation, which is to do the user related settings. This has speed up the process of automation, standardize the process of cluster creation. But more than that, this is these 6 layers are independent of each other, so it brings a level of modularity into the entire solution. So even if you would want to use one of these, if you would be easily able to do that. So that's the level of modularity or reusability, I would term it that way. Taking one step ahead, we have integrated Kubernetes upgrade, which not just upgrades to Kubernetes, but it also updates all the certificates, everything related to the platform. So to give you an example, we publish a maintenance calendar at the start of the year. We take change windows, and in single change window we do all the maintenance activities, whether certificates, any configurations, any updates, Kubernetes upgrade, everything is done in that single window. So it has helped us in increasing in saving our efforts, and also in getting the change window from the business easily. Last under this pillar is everything as a code. So we really capitalize on the trend of thinking of everything as a code, whether it's infrastructure, whether it's environment, configuration, policy, anything you can think of, we think of it as a code. Second pillar here is SRE. Under SRE, we have SLOs defined for all the critical parameters, and particularly availability and connectivity, because these are the ones for which we have SLAs and penalty implications from the customer. Then under alerting and monitoring, we used to use Grafana and Prometheus earlier, but it was too cumbersome. In this sense, we had different dashboards for different parameters of different clusters, and set aside troubleshooting, but even making any changes in the alerting stack, any single parameter, we had to do it multiple times across all the clusters. So thinking on this, we have now moved to Datadog, which is a centralized system where we have single dashboard, single um, place where all the parameters are defined, and if you change the parameter, it gets changed for all the clusters. So this is helping us in increasing our troubleshooting speed, because everything is at one place. Secondly, it also helps us in making any changes in our alerting stack from configuration or parameter perspective. It is now faster. The next thing comes under SRE is capacity planning. So we have automatic triggers set up for all kinds of resources that we have once they reach a specific threshold, and then it is followed by scaling recommendations, and all of this has resulted into toil reduction. Last pillar here is continuous improvement. So at one point in time, we realized that our CNI plugin Weave had some inherent issues. To be precise, there was an issue called Weave split brain issue, wherein duplicate IP was getting assigned to multiple pods, and then there was a lot of confusion around the communication between the pods. So we have changed from Weave to Calico, and it has stabilized the system all the more. We've already spoken about IPsec to WireGuard transition. Next thing that we have done under improvement is LVM setup or logical volume manager. So encryption is an inherent part of this entire system, and encryption was something which was eating up a lot of time in cluster creation. So we came up with this concept of logical volume manager, wherein what it essentially does is it um, divides your disk into multiple partitions and starts encryption on each partition simultaneously. So it has speeded up the um, encryption process. Last thing here is a quota setup, because at one point in time we used to get a lot of pod eviction related issues, we due to non-availability of resources. So now we have set up quotas at a node level and at a pod level, so we no more have any issues related to unequal distribution of the resources. And all of this that we have spoken about so far across these three pillars has quite quantifiable results. If you see the graph on the top, at in October 2020, we had 2357 alerts, whereas till we reached the May 2022, it's 12 alerts. So it's a clear cut 99% reduction of alerts count. Then from regular P1s, we haven't witnessed P1 in last 9 months. Our delivery satisfaction index has improved from 5.78 to 1 being the best. And more important than all of these, our contract with client has got renewed for 3 years without floating an RFP. So like this, there have been a lot of learnings out of this project. And of course, we've been sharing those learnings with the other projects as well. But taking one step ahead, what we've done now is we are building a service pipeline around it so that it can cater to any requirement. And that is something Rohit will talk about, the service pipeline and the data ops model that we have set up. So with that, I say thank you and I hand over to Rohit.
Thank you, Arpita, and thanks a lot for going through all the technical details, project details, setup in detail. And from a business significance standpoint, I think you explained well. Now, continuing that, going forward, I'm going to take a step back, as Arpita said, and talk about three things. Number one is obviously the data ops part of things and how we wanted to do it. We'll also talk, I will start first with the SRE usage, the use of site reliability engineering principles. How did we put in, and I'll try to correlate that with the decision making, which Arpita already talked about, and also the future and the reusability. And that is where we, Juno being our flagship project from container COE, it makes sense that we learn from what we have done for Juno and then take this forward from a reusability standpoint. To start off with, for the next slide. So to start off with the site reliability engineering and data science part, right? Now, I've been talking for some time about how we can actually use site reliability engineering in a way which takes adoption as its journey. If you remember, Arpita talked about SRE and continuous improvement separately, and there is a reason for that, because for this particular engagement, we made some really changing decisions when we started following the principles or adopting the principles of site reliability engineering. So the introduction of obviously decision making based on data had to be done. Usage and introduction to data ops had to be done. We wanted to get into a predictive mode, and I'll give you some examples on how did we try to do it. But before that, the first thing was we had to put down an SRE charter as to what do we want to do, right? And we quickly figured out that reliability from an SRE perspective will come down to high throughput, okay, which will which will obviously result in reduction of toil. And in our opinion, it was better that we take some real good decisions to look at why our esteemed colleagues and brilliant engineers are spending so much of time in looking at alerts and why there are so many problems. You saw the history of the project which Arpita showed, and initially it was a bumpy ride, a very bumpy ride, to be very honest. So the core principle of SRE is for effectiveness. In this case, we chose throughput, as I mentioned, which would have given customer satisfaction and a sense of reliability. Now, how do you define that throughput, right? So we had the quantitative and the qualitative part of things. One was the quantitative part is from a perspective of technical decision making, which we took. So we mentioned about Prometheus, removal of Prometheus and Grafana, and movement toward Datadog. That was one of the outputs which came out of our reliability principle following, and SREs came back with proper discussion, and then we took that decision. Movement from IPsec to WireGuard, Arpita, covered it a little bit. Calico usage, and also what we are doing right now as we speak is, while we had great automation put in place via Ansible and even the orchestration part, which is unheard of, we are actually moving to Rancher as we speak. All of this decision making is happening based on SRE principles of managing toil, right? To ensure that there is simplicity in decision making. Now, from a quantitative standpoint, exactly for this purpose, if you see on the top right hand corner, we started not only looking at the ITSM data, alerting data, but also started looking at how we can make our lives easier. When I say lives easier, means we can deliver quicker. And to the usage of SRE framework model helped us. It is a model which has been developed in container COE as we speak, and the improvements which were put in place were from a reliability and achieve reliability at any cost. That was the point. Now there was a tinge of data operations, data ops put in over there. Now one part is obviously moving to a different tooling. The reason for that was to gain better observability, but at the same time we also wanted to really imply predictive maintenance, especially where it was on the algorithms which are not, giving outputs which are not visible to naked eye as we speak. So we wanted to be proactive, right? One is doing things quicker. The second is we are doing things even, or preempt things even before we do it. In this case, we started putting in a time series setup. Obviously, VM-based time series setup is something which we already have from a prediction standpoint, but we really wanted to put it at different pods, clusters, nodes, and look at the network traffic. Something which will not say that we have mastered it, because it's a very new field and sometimes we don't even get the data out of it, but the correlation which comes out of it at runtime from different components was something which gave us an edge from an SRE standpoint, from an observability standpoint. That's number one. But number two, the more important thing which we are working on is doing that correlation with predicted data across different components, across different areas. Now this is an homegrown IP based solution which we are trying at this point of time using DevOps. At this point of time we don't have too many machine learning pipelines, but we do have two of them, and both of them are exactly for the point which I mentioned just now, which is about trying to do a correlation on predicted data. One is obviously for the real-time data, but one for the predicted data, and see how accurate do we get there. The good part is that we have the control of the data. Even better part is that now, since we have made the change from a quantitative standpoint, from a reliability, obviously, and that has affected in great satisfaction from the stakeholder side. But at the same time, we have also ensured that we are close to quite modern when it comes to tooling, so that when you are there and when you are the best of what you can do from an observability standpoint out of box, you try to push it further by applying your own thoughts, and that's where the data ops comes into picture in this particular project. And the most important thing is, since we come from a SI based background, right, so system integrators, right, there is always an aspect of future, what to do with this and what do we learn from it and how do we go and use it and reuse it going forward, right? And that was one of the areas why we formed the container COE also, because we didn't want to just run a project in isolation and be happy about it, but we also wanted to ensure that we do reuse what we have learned from Juno. And Juno being our flagship project, we did go through a lot of grind and we have come out with a lot of aspects which can be worked upon. Apita, next slide, please. So the other aspect of reusability is based on a small setup which I show you just now, which is about the fact that based on our learnings which we had through different tooling, we put in a common pipeline. We try to put in a common pipeline. This is applicable now for more than one customers as we speak, but it is still very much in a work in progress because there is no limit to this. The reusability part was to create a sort of a landing pad for any container based workload based on our experience with Juno. If you see, there are some different tooling which you see on the screen compared to what we discussed in Juno, because we thought that it would be helpful for us or helpful for the customers to do if we stick to this sort of tooling pattern. where we can accommodate all the other tools and package it and through the help, deploy it on, say, uh, K8 on-prem install like we have in Juno, or EKS or an AKS, or any of the public cloud installations if we need to. The two most important thing which we had to keep in mind was, one was the integration with the management tools, which includes ITSM and a lot, and the second was logging and monitoring. If you see, we are planning to use ELK for that, but at the same time it doesn't stop and limit us from only using that stack. We have Prometheus servers also, we have Grafana usage also, and more so we are exactly at that point of time is where we are trying to put in the data ops model in place, so that we try to give it out of box as a, as a plugin, so that anybody who uses this pipeline will get all of these integrations and all of these predictive models by default. So this was the future which we are looking to, the reusability aspect of it, the learning which we have. uh, Juno is unique because it has a lot of security features inbuilt into it, and that's why it is unique. But tomorrow we might get even more complex projects where we have to do this sort of integration and run the CI/CD pipeline and ensure that we provide the service delivery. So that's all I had from my side to cover from an SRE, from a data ops, and from a future and reusability perspective. Back to you, Arpita.
Conclude, what we can say is we need to reach to a point where we have a self-service portal for the customers, where we have all these offerings with respect to logging, monitoring, service discovery, CNI plugins, even for that matter, for a multi-hybrid cloud perspective. And that's the reason why we are going ahead with Rancher, and moving away from Ansible, so that we have multiple hyperscaler offerings as well in this offering. Customer just has to probably select his or her requirements, and rest all will be done by this service pipeline. Of course, there will be certain recommendations from our end that will be the next level of this, but to start with, at least we need to have this end-to-end product with the flexibility to customer to choose any of the tools they need, and to reduce their work of laying down the requirements and checking the backend infrastructure. So that's the aim. With that, I would like to again thank DevOps India Summit for giving us this opportunity to talk about our project, to talk about our future vision. And we just hope that this will be a learning for the people who are seeing this presentation. And if even if it reduces their efforts by 20-30%, we feel that we have done our bit. Thanks a lot.